Hey, we're doing some intermediate algebra notes today for the discriminant of a quadratic. So first off, let's talk about what is a quadratic function. So what does that word quadratic mean? Quadratic means that in your problem, the highest exponent is a 2. So things like y equals 3x squared minus 5x plus 1 is a quadratic equation because the biggest exponent is a 2. Okay, we don't care what the coefficients are, like the 3 or the -5, or even what this constant is a 1. The 2 exponent is what we're looking for. All right. So we have a parent function. It is y equals x squared. So a parent function is the most boring, simple version of a certain type of function that's possible. So what is the most boring quadratic? It's just good old y equals x squared. So let's see what that looks like. If we were to make a table, we would pick x and y as our two variables, and then we would get to choose what x values we want to use. Well, since we're making a graph, and generally we want to pick small numbers anyway, let's pick the numbers -2 through +2. Okay. We're going to take the -2 and plug it in here for x. So it's y equals -2 squared. Well, negative times negative is positive, so that's a 4. Okay, the next one is -1 squared. -1 times -1 is just 1. 0 squared is 0, 1 squared is 1, and 2 squared is 4. So pretty similarly to when we were doing absolute value functions, all the numbers on the right-hand side end up positive for our parent function, and we also have that point 0, 0. Okay, so let's plot all of those points and see what we get. So if we plot 0, 0 here, -1, 1, 1, 1, -2, 4, and 2, 4, we kind of have a mirror image going on from the left to the right. That is called a parabola, this shape. So this curve is called a parabola. Just like in absolute value functions, we had a vertex. In the absolute value function, though, the vertex was the pointy point. So the vertex was like a corner. In a parabola, though, the vertex is just like that bottommost point. So it's when you're going from like decreasing in the function to increasing, meaning your graph goes up again, that's where that vertex is. Okay. Please notice that on these graphs, we are going to have a curved bottom to it. So it is curved, not pointy down there at the bottom. So don't make it very sharp when you draw this. Okay. Next, let's talk about a quadratic equation. We had standard form that we did like a while back, like way back in August, we talked about standard form. We had things like y equals ax squared plus bx plus c. Now, we didn't use the a's, the b's, and the c's, but really what we were looking for is that your first term with x's has the x squared, the second one has x to the first power, and then your constant goes last, the one that doesn't have any x's. So our exponents go from biggest to smallest. And since this is a quadratic equation, we know that the biggest exponent has to be a 2. So this is our standard form of a quadratic equation. Okay. Next thing I want to talk about is minimum versus maximum. Okay, if a, which is the number that's attached to the x squared, if a is a positive number, the graph is going to be a curve that faces up. A lot like when we did those V-shaped graphs for absolute value. If the front number was positive, our V-shape went up, like normal. So I'm going to call those a smile, but in most math classes, they're going to say like opens up or curves up or something like that. The vertex on this graph is the very lowest point. So we call the y value there a minimum. So what is the very, very lowest that we end up going? Whatever that y value is. That is your minimum. Okay, so if a is positive, you have a minimum. Next one. If a instead was a negative number, that means that your curve is going to point downward, like a frown. So you end up with that reflection. So pointing down like a frown, The vertex is the very highest point, so that's where we switch from going one direction to going the other direction, so like flip back down. The y value of that vertex is the maximum. Okay. So let's take a look at examples 1 and 2 down here. We want to circle whether the equation is quadratic or not. These are all going to be functions, which means that each x value we input can only give us one y value. If the function is quadratic, we want to label a, b, and c, and then circle if the vertex would be a minimum or a maximum. So that's a lot just based on a few numbers here. Okay, let's take a look at example number 1. We have f of x equals 5x squared minus 3x plus 1. The biggest exponent here is a 2, and that is the definition of a quadratic function or a quadratic equation. So yes, example 1 is a quadratic function. Let's start with a yes. Okay. Next piece of information, we want to know what is A, what's B, and what is C. If all of your terms are in the correct order, so biggest exponent all the way down to smallest exponent, then all you have to do is grab the numbers that are in front. So 5, -3, and 1. Okay. I drew a little smile over here off to the side next to A equals 5. I did that because if A was a positive number, so positive gives you a smile. If you're in a positive mood, you're happy, so you smile. If you're in a negative mood, you are sad, so you frown. So if this is positive, smile. Okay. So last thing on here is the vertex going to be a minimum or a maximum? Well, the very bottom point here on the smile is going to be either a minimum or a maximum. Minimum means lowest, so that point is a minimum. Okay. Example 2. Example 2 is not a quadratic function. The reason is because this 3 exponent is not a 2. 3 is bigger than 2. Spoiler alert there. So, not a quadratic function. Since this is not a quadratic function, we don't have to do the a, b, and c or figure out a vertex because there isn't one that we can find. All right, moving on to examples 3 and 4. Okay, example 3. The biggest exponent is a 2. Awesome. Let's go ahead and put these terms in the correct order. So instead of having the 3 first and the x squared second, let's swap that around. So f of x equals -4x squared plus 3. 2 is the biggest, so yes, this is a quadratic function. Part of the reason why we wanted to put the x squared term first is so that a, b, and c are the easiest things to find. Okay, remember that a is the number that's multiplied to x squared, b is multiplied to x, and c is a constant. C stands for constant. Okay, so a has to be that -4, and c, the constant, is 3, but there is no b value. There's no bx term here. So the number that b must be is 0. Okay, the bx term is missing, so b equals 0. We've done that several times before where if there's nothing added on, you can add a 0 and it doesn't change the problem. All right, so we've got -4 for A, 0 for B, and 3 for C. To tell if we have a smile or a frown, we always look at A. A is negative here, so the graph is going to be facing down. Our parabola curves down. Okay, this point right here is our vertex. It's where we switch from going one direction to going the other direction. So up to down or down to up. That's the vertex. The vertex is at the very tippy top of our graph. So that point right there is going to be a maximum. Okay, the y value of it would be considered the maximum. Last one on here, number 4. We have f of x equals x minus 3 times x plus 4. Now, that is definitely not written in standard form because we have 2 factors that are multiplied together. So it looks like we're going to have to distribute and combine some like terms. So distributing, we would multiply x times x is x squared, x times 4 is 4x. Then we move over to multiply -3 times x is -3x, and -3 times 4 is -12. And we combine these like terms here, so 4x minus 3x is regular old 1x, or just x. Okay, you're always welcome to write those invisible ones in if you want to. So it'd be 1x squared plus 1x minus 12. Since the biggest exponent is a 2, we do have a quadratic function. Okay, so yes, and then a, b, and c are 1, 1, and negative 12. Okay, a is positive, so we have a smile. Vertex is down here at the bottom, so bottom vertex is a minimum. Okay, next thing here is discriminant. Okay, it is discriminant, not discriminate. Okay, we have a formula for the discriminant. The formula is d equals b squared minus 4 times a times c. So your job is to plug in the numbers that we found for b, for a, and for c into these three positions. Okay, you take whatever b is and you square it, so that means multiply it times itself, and then you subtract 4 times a times c. Notice that 4a and c are all multiplied together in one string. You are not distributing this 4. You just multiply 4 times a times c, all in one string. Okay. The discriminant is something that tells us how many times our graph is going to cross over the x-axis. That's going to be a recurring theme all throughout quadratics. How many times does your graph cross the x-axis? And then eventually you'll want to figure out, where does your graph cross over the x-axis? And we end up doing that in the very next section using the quadratic formula. So this set of notes right here is kind of a gateway to using the quadratic formula. All right. We have 3 different options. Our discriminant might be negative, our discriminant might equal 0, or the discriminant might be positive. Okay, so those are the only 3 options, negative, 0, or positive. Okay, if the discriminant is negative, what that means is that d equals a negative number, and we are going to have 2 imaginary solutions. Okay, we're going to spend some time dealing with imaginary numbers, which are also called complex numbers. Okay, there's whole branches of mathematics that are based off of complex numbers. We're just going to do enough to get you into like algebra 2 or college algebra. You'll definitely end up seeing these again. So let's make sure that we understand them while we're still in intermediate algebra. Okay, the discriminant might equal 0. 0 is a pretty cool number. 0 means that we are going to have one real solution. Okay, so real numbers versus complex numbers. There's a difference there. Okay, and the last one, if the discriminant is positive, discriminant equals a positive number, you're going to have 2 real solutions. Okay, this one shows up the most often, that you end up with a positive number, because math teachers really like it when you can actually work the problems, and you can only really work the problems if you have 2 real solutions. This one you don't have to show as much math, and this one sometimes teachers just kind of have you stop and not actually find the imaginary or complex solutions. So this one's going to show up over and over. We're going to get 2 individual numbers for our answers for x. All right. Let's start with number 5. Number 5, we start by either getting y by itself or 0 on one side of the equation. Okay, so if there's no y in your problem, then try and get 0 on one side of your problem. So y or 0, either one. Okay, make sure that your other terms are in standard form. So we have x squared first, and then x, and then our constant number, so that we can grab those 3 numbers just like in order, 9, negative 4, and 5 for a, b, and c. Okay, our discriminant. The discriminant is d equals b squared minus 4ac, right? That formula is right up here. So we're going to take b and plug it in here and square it. So that is negative 4 squared. Then put minus 4 times, a is 9, times c is 5. So it's negative 4 squared minus 4 times 9 times 5. If you are plugging this into one of the graphing calculators, make sure you are typing a negative here, and make sure you are typing a subtract sign here. Okay, if you accidentally switch those up or just do one instead of the other one, it messes up what your calculator is thinking, so you're telling your calculator to do the wrong thing and it freaks out. Or it gives you the wrong answer, both of which are bad things. Okay, so you can do this out by hand and squaring. You get negative 4 squared is a positive 16. This number is always going to be positive because when you square any number, negative times negative or positive times positive, you get a positive number. Okay, over here, negative 4 times 9 times 5 is negative 180, so you bring down negative 180. And then we subtract 16 minus 180 is not 160, it should be negative 164. That should be a 4. Okay, so whatever the number is right there, it is negative. And if we have a negative number for the discriminant, we end up with 2 imaginary or complex solutions. So the solution type is 2 imaginary solutions. You have to say how many and what type they are. Okay, 3 more problems. This should go a little bit faster for us. Okay, so first off, we need A, B, and C. A is 1, B is 2, and C is 1. So you might think, why is that? Because don't we have a negative 5 right here? Aha! Our problem does not equal y, and it does not equal 0. So we have to make this number equal 0. To get rid of a negative 6, you just add 6 to both sides. And we get x squared plus 2x plus 1 equals 0. That is not optional. You have to get 0 by itself. All right, so 1, 2, and 1 for A, B, and C. Okay, let's find the discriminant. The discriminant formula is D equals B squared minus 4AC. So 2 squared minus 4 times 1 times 1. 2 squared is 4. And then negative 4 times 1 times 1 is negative 4. And 4 minus 4 is 0. The other option is you plug this whole string of numbers, start to finish, parentheses and everything, into your calculator, and it will spit out 0 for you. Okay, if your discriminant D equals 0, you have one real solution. Okay, number 7, we again do not have 0 by itself. We do not have a y in this problem, so we need to solve to get 0 on one side of the equation. It doesn't matter which side. Okay, so let's just add 9 to both sides to get a 0 over here on the right. Adding 9 gets us 7x squared minus x plus 18 equals 0. So A, B, and C are 7, negative 1, and negative 18. Now you might wonder, like, how did that 7x squared end up in the front instead of second? Well, we can just switch 2 terms as long as they're on the same side of the equation. So 7x squared minus x instead of negative x plus 7x squared. All right. So we rearranged to put the ax squared first, putting it in standard form and making it easier to grab the 3 numbers. All right. B squared minus 4ac for the discriminant. So that is negative 1 squared. Notice the negative 1 is inside parentheses. Minus 4 times 7 times that little squeezed in 18 there. Okay, negative 1 squared is 1. And negative 4 times 7 times 18 is negative 504. So 1 minus 504 is negative 503. Since we have a negative number again, we end up getting 2 imaginary solutions. Okay, so negative numbers give us imaginary solutions when the discriminant is negative. All right, one last problem. We've got no 0 and we have no y equals. So let's get this negative 7x over to the other side by adding 7x to both sides. So we get 5x squared plus 7x plus 3 equals 0. Okay. We can now figure out A, B, and C. It's 5, 7, and 3. And yes, this is a quadratic because we have a squared. Okay, so 5, 7, 3 for A, B, and C. Since 5 is positive, we have that smile. Vertex would be at the bottom, so we would have a minimum. Let's figure out our discriminant. Discriminant formula is b squared minus 4ac. So that is 7 squared minus 4 times 5 times 3. Remember that all three of these pieces here, all three numbers are multiplied together in one string. Okay, so when you either do that in your head or plug it into your calculator, you're not doing 4 times 5 and then 4 times 3. It's just 4 times 5 times 3. Okay, 7 squared is 49. Negative 4 times 5 is negative 20, and negative 20 times 3 is negative 60. Combining those like terms together, you get negative 11, which is, again, negative, giving us two imaginary solutions. So we never actually ended up with any positive numbers for the discriminant, even though this is the most common type of problem. So I would imagine that on the back of this page, you are going to get some actually real solutions.